camera, and then hopefully we'll launch. And the next speaker is the guy that will determine whether we launch today or don't launch. Weather Officer Barrett from the United States Air Force.
No pressure there. Yeah, the one nice thing, I know probably most of you were looking this morning and maybe we're sitting in a tent as a few rain showers went by. And we had a nice little lightning show early this morning as well. The one nice thing, all of that was associated with the front, which has pushed through us, and that's the last we should see of the lightning and the showers throughout the day. We still have a few low-level clouds. Currently, the weather is red for ceiling constraint, which is low-level clouds where they cannot see the orbiter. We expect those also to push through roughly around the noon time frame, and hopefully here have a fairly cloudless view of the launch. We still are at right now a 70% chance of having favorable weather. We are concerned about winds. As you can tell, it is a bit breezy outside. And right now, the wind direction is actually working in our favor. Even though it is pretty breezy, the direction is coming straight down the runway, and we would be okay to launch currently. However, the forecast is for those winds to shift around a little bit more coming out of the ocean. And if we have these same speeds that we have right now out of the ocean, we would actually be violating wind constraints. So that is our concern. We do expect it to die down a little bit. You may not notice that much of a difference, but we only need a few knots lower as that shifts around out of the northeast to give us favorable conditions. So we still are optimistic that for launch we're going to have favorable weather. And we are continuing to monitor the conditions throughout the day. Still have a lot of time left. We'll see some changes as we go. The clouds, like I said, will continue to move off, and we should have good conditions. That's something that we do on a regular basis. We have a weather team that is over on Cape Canaveral Air Force Station in the Morale Operations Center, which is looking at field mill equipment, number of wind sensors that we have on towers throughout Kennedy Space Center and Cape Canaveral Air Force Station. Specific equipment that we have to monitor all the conditions, which help us provide forecasts and observations for launch time, as well as all the processing that goes on before launch. Last night, if you're watching some of the news, they were talking about a delay because we had some pretty intense thunderstorms come through the area yesterday afternoon through the evening time frame, which delayed a lot of the processing that they had scheduled. That is something that we monitor, provide them information, and give them forecasts so they know if they have enough time to pick up the launch count, which we did. Most of the storms ended before midnight, which allowed them to pick up the count and rotate the RSS and expose the shuttle, which is a very important task before going into tanking. Those storms were basically caused from a couple interactions, and that's something that we have to look at every single day. Here in Florida, with the way the Cape is formed, we get a lot of sea breeze coming off the ocean. Land heats up, it gets hotter than and out over the water, which then forces the air to move from the water over the land. When we get that sea breeze, a lot of times we'll actually get thunderstorms developing right overhead. Last night, we actually heard there's some hail sightings out over Titusville to our west. Those storms were actually developed from the outflow of a thunderstorm that it kicked off to our northwest with the front. That thunderstorm produced winds come out of it, more clouds develop, and that tends to move. That interacted with a sea breeze, which had enough lift to create those thunderstorms that we saw last night. The other part that goes along with that, something that you normally don't see in Florida, is hail. With that front passing, there's a lot of cold air up at the higher levels, and one thing you do need for the formation of hail to hit the ground is that cold air has to actually be low enough so that in every thunderstorm you have hail. it's just so high that by the time it falls out of a thunderstorm, especially here in Florida, it basically melts by the time it hits the ground. With that cold front coming through, the level of where that freezing level is dropped down low enough that we actually saw some hail out in Titusville areas and got reports of hail hitting the ground, decent sized hail. But it's all because of that interaction with that front you just saw come through, plus the sea breeze, which we tend to get here on a regular basis and have to continually monitor. But fortunately, everything came through nicely. We got that decrease in storms. Most of the energy of that pushed on, so we could, the mission management team could go ahead and contract the service structure and continue with processing for the launch. So that's a lot of things that we do. The weather squadron on Cape Canaveral Air Force Station does continuously, day in and day out, 24 hours a day, providing the monitoring of all the winds, lightning, the storms, hail for the orbiter processing, as well as the unmanned launches that occur over at Cape Canaveral Air Force Station. So right now, like I said, we are looking favorable, 70% chance of having favorable weather. And our biggest concern is going to be the winds, which we should see die down a little bit and also shift out to give us a nice view for launch.
Are there any questions for Lieutenant Colonel Barrett? Please keep your hands up and we'll try to get to you.
I'm just curious to know if you know what the current situation is with the house.
Yes, currently there are actually two organizations. The 45th Weather Squadron here works weather for processing and for launch. The other organization is Spaceflight Meteorology Group out of Houston. They handle the forecasts for the TAL sites, which the transatlantic abort sites, as well as they actually do the landing forecast here at Kennedy Space Center. We're in coordination with them, of course, for all the forecasts. Right now, the TAL sites are currently all three TAL sites, Marone, Istrus, and Zaragoza, are all forecast red conditions. They're all forecast red for a chance of rain showers within 20 nautical miles. And of course, that is another impact to the mission management team. We need to have at least one TAL site which is forecast green GO conditions as well as observed GO conditions. Last report I had, both Istrus and Zaragoza were currently observed red, and Marone was observed green. But right now the forecasts are still all for red conditions, and that's something that the Spaceflight Meteorology Group out of Houston will be continuing to monitor. And we get observations from all three sites and talk to the folks. And as we get closer, usually what we'll get is an update as we get in right before coming out of that last hole for an update on the TAL site weather. And so that's something that we're watching as well. And basically, that's sort of when the last update is. There's a few different time slots throughout the count that we provide weather briefings for. Spaceflight Meteorology Group does provide the weather briefing to the astronauts before they head out to the orbiter and get suited up. And then we also, for launch forecast, Kathy Winters, our launch weather officer, provides weather briefings to the mission management team. Usually their last briefing is an hour out, and then as we get closer to come out of that last built-in hole, both groups provide input for the mission management team. So, to answer the question here, all three are forecast red at this time.
My name is Chris, and I'm like probably the average demographic in this room. I'm old enough to remember watching, as a child, watching some of the early launches from the nearest site. And I wonder if you could speak about what's the biggest changes in how weather is monitored now compared to the early days.
Well, I'm sure in the early days, you probably didn't have as much equipment as we have spaced out along the Space Center. Right now, the one thing we do have here, we probably have some of the most advanced weather equipment, weather sensing, and computer modeling here at Cape Canaveral Air Force Station to cover both Kennedy Space Center and Cape Canaveral as anywhere in the world. Some of the biggest things that you see from the early days, in the early days, yes, included in that. It's, right now we use a lot of the computer graphics. You can even see it on the internet. There's a number of places where you can actually look at your own computer models and see streamlines, take a look at cloud analysis, and see how things move. Previously, we would have paper products. You still have the analysis, but you actually did it a lot by yourself on your own hand, drawing out all the streamlines, taking a look for all the little features that might kick off something related to launch. The other thing is the field mill network. Of course, as with everything else, just like the iPods, iPhones, everything gets better technologically wise. And the same thing with our sensors. They've gotten more accurate, and we're able to put more in. All of those sensors we've been able to feed in through the computer system that we have to monitor, take a look at all the trends. And a lot of that is just from technology, just taking advantage of it, just like everyone would with a new phone and different things like that. The techniques we use are basically the same. Over that time frame, we put together a lot of rules, basically rules of thumb. Sort of like the old, farmer's almanac. You look up the almanac and it says, oh, this time of day it does this. Well, we have those same kind of rules, or a little more specific, of course, related to temperature and what are the clouds, what's coming in, which way are wind directions, and all that. And we constantly develop and refine those rules to allow us to provide more accurate forecasts. The other thing that's changed is our knowledge of what causes, for lack of a better word, basically lightning when we have anything going up through the atmosphere. And there's been a lot of research. Unfortunately, we've had accidents here at Cape Canaveral, but through that, it's allowed us to come up with more research to make sure that we have the constraints we need to make sure that the launches are safe and successful. So that's probably the biggest thing, just all those research on what does cause lightning strikes to happen. Not just lightning itself, but actually just going up through a cloud, sort of like walking on a rug and providing that electric shock to your buddy, and he jumps up 3 feet in the air. Those are the things that we're looking for, and just a lot of that in the sensors and just the knowledge we've gained over the last 20, 30 years to help make the launches safer.
Hi, Zach Paul, meteorologist. Just curious as to, you kind of hinted at the different computer models that are available on the internet. So I have somewhat of a two-part question. The models that are available on the internet, are there other models that are available to you that aren't available to the public? And then two, with wind being the primary hazard possibly for today with the switching, what different levels, what different heights would you have to worry about, and what is the knock criteria, the speed criteria that would stop the launch?
Okay, with basically most of the models you get over the internet we use as well. They're more of a larger scale criteria. We've developed in-house some more localized products that deal specifically with sea breeze effects and localized effects. And so those are the kind of models that we've got developed for us with, there's the AMU, which is a NASA-sponsored organization that works with us that creates localized models for us to plug in and use our localized data. So those are the types of things that we have to build upon the standard models that you would see over the internet, and helps us to get a better handle on when we'll see thunderstorm development, when we'll see higher winds from thunderstorms, and when we might see some of the hail.
High resolution.
High resolution. The other thing that it does is those models that we have they're specific to the time of year. Here down in Florida is a little bit different. When we get through winter, we'll have what we call a transitional season. It's sort of like being in Colorado or up in the Northeast, where we're looking at fronts coming through to produce our weather. When we get into the summertime, we actually transition to a tropical type environment where we actually see thunderstorms develop. We don't need the front, we don't get the fronts pushed through, but we'll actually see that. So our models are geared toward the time of year to give us the information that we need. So nice high resolution and based on local effects. And now I forgot the second question.
The winds, different. Is there a certain level that's
there's a couple of different things with winds. One of the criteria they look at has to do with upper level winds. It's the wind profile when you go from surface all the way up, through 60, 90, 100,000 feet. That wind profile is actually, with our weather balloons that we send up, we process that data and send it to NASA or to our customer, who sends it through their computer model, and they figure out whether what they call a loads profile is too great or not. And that's something that's completely computer driven, and that's based on the ability of the shuttle or another launch vehicle to handle the different wind stresses as it's going through to make sure it stays on trajectory. The winds that we work with on a daily basis, we have wind measurements at 6 feet, 60 feet, all the way up to 500 feet. And our wind criteria for launch are really based on like a 54-foot level. So that's the main criteria we use, and it's based on the tower direction for launch. And that is, I think right now, it's based on direction. So it's sort of depending on direction, it goes up or down. Based on our forecast direction, the wind criteria we have is about 28 knots. There's also another criteria that we have to monitor for return to launch site. And that's the one that usually comes into play. And it's sort of like any aircraft has certain wind conditions where it's going to be too much. Based on our forecast, we're looking for the winds out of the northeast, and that is going to be a 19-knot crosswind constraint. So if we get the winds that hit 19 knots, that would violate our wind constraint for the RTLS. So it's sort of, it's a as it goes kind of thing. If it goes out of a 330, there's no wind. It goes up to like 34 knots. But then as it changes direction, it will drop down as low as 15 knots. So it depends on direction.
Thank you. I think we're right on schedule. Really appreciate your time, Ms. Pro.
Who's the best?
A couple of quick announcements to make before we break for lunch. Try to make sure you can. We have our escorts. They're going to come up in a second, so you know who they are, and they'll get you over to the cafeteria if you'd like to go. The other thing is we want to make sure everyone at about noon, because around 12:05, the Astro Van's going to come around and take the crew to the launch pad. So you want to go through the parking lot where you parked yesterday, and that road, the road that's adjacent to the parking lot. Just stand out there, and the group will all come out and meet you at 12:05. Hopefully they'll come by and wave. And I think Astro Flow is probably very focused on SH-129, but there's nothing else like that. So in the past, there's only a few people out there waving. Also, 150 people descending on them. I think it does make quite an impression. So we're looking forward to that.